Hello, let's get started. I today will show you some Docker parts of the SensGuitar and why we use Docker in the SensGuitar, what is great about Docker and what is not great about Docker, and what are some problems if you use Docker in an embedded environment with in a multi-display setup like ours. So, first of all, switch to the main monitor and let's take a look that Docker is here running. So Docker is inside as you see. And to see it a little bit more clear, you see that we have at the moment two containers running. One of the containers is called Western and one of the containers is called main menu. So you see at the moment these two containers on the little display. Let's make a watch on Docker PS. So a watch will now every 15 seconds show us the new content of this and open in a separate split the windows maybe. I think this is a good idea. So then we can have see the watch on the one side and on the other side. We can type something. So let's start the fire animation and see what happens. As you see now, the containers are removed or stopped. A new container is started, and if you've seen for a short second the time and so on, this is because if you start if you can now stop the fire animation, then you see only the Western container of the first display. Let's take a look at it. So, as you can see, the display is now gray because only this was running. We have a little lookup script and our health check has seen that no application is running, and so we switch back to the main menu. If you can imagine, I can now stop the start script and we can do it again. And then you will see the whole Western container, like seen before in some other streams from me. So, the Western container is stopped on the first display. Oh, okay. A little bug appeared, I think. If you have to use more than one Docker environment it is much more easy, yeah, to use a Docker Compose file. But here are now, you can see some downfalls in the Docker in the Docker implementation. As you see closely, as you can see, I unsplit the view for a moment to show you a little bit of the code. As you see here, this container, or Western container, is started without any dependency. Our first and our second application depend on these one Western container. As you can see in the logs very closely, you see that of course the Western container starts first, but then after it starts, in the startup phase of the Western container, the other two containers also start. So it can be possible that here the display is created but can't be used at the moment because the application has started, but the display is not opened. I have a short problem and I will come back in a minute. Sorry for that. And I'm back. So, sorry for the short interruption, but I have to check something and this was important. So, as you see here, these containers does not start when our Western container is completely started, because at best it would be if they start, if this messages appear X server listening on display blah. So I think for that reason we should try today to take a look at the Docker startup and how we can manipulate this startup. Yes. So let's go back to the main monitor and take a look how to do this. I have seen this before, and all in all, Docker suggests use a tool such as wait for it, Docker size, shcompete wait for, read template. So I have not used this before, and I think the best would be to use something like wait for it. but for our purpose, this is maybe not the right one. Interesting. So I think with wait for is a good candidate. I have not used it before. Service depends on backend build, backend command. Wait for, okay. It's really just a bash script. So yes, with that it would be possible to implement better startup of our containers. Let's maybe take a look at our containers we have at the moment, what the containers do, where they come from, and if you like, how you can download it yourself. So let's switch to some of the code. And as you can see, the most of our containers come from Horizon. So let's take a short look on Docker Hub what Horizon containers there are. There are some .NET stuff. I should sort it maybe a little bit better, but of course. Cookies, cookies, cookies. So let's take a look. These are uninteresting containers for us at the moment. The Debug Port toolchain container is part of our Visual Studio environment. As you can see here, I would not use this container without the Visual Studio if I'm honest, but it is possible. We have tested this. The cross-chain container is the same. So some test containers, of course. And now I think the interesting part comes. There were the Wayland Qt5 examples of Toradex and the Wayland and Debian based containers. I think these are also the most downloaded containers. It's a basic Debian image, and the Wayland base image we can also take a look. I think this is maybe interesting for someone. And the Western. So, as you maybe know, Western is a back end and Wayland is a front end for the graphical application like Wayland in the Linux environment. So I don't think this here really interesting points. You can also view the whole code in their GitHub space. So there is a Toradex GitHub. Toradex GitHub Docker, where you can find all the Docker files from them. At the moment they use Bullseye, and so we are based on these. Now let's go to our containers and what they do. As you can see, you can find every of our applications at the moment directly on Docker. The code we have not provided at the moment, but if our Kickstarter is successful, we will provide you, of course, all the code. You see here that we have the main menu, which you see on the little display. I can show it to you if you like. The effect chain for adding the overdrive or the octave effect. All in all, the effect chain container is a container which opens a TTY terminal and send a UART signal from our parlors to our FPGA, and then the FPGA activate the needed effects. SensGuitar Notion is at the beginning and does not do much. Display 1 and Display 2 are our display containers. RE is a special one, but not interesting at the moment. It is used for flip the container, because sometimes we have things that this kind of programming is a little bit easier. SensGuitar update is our start of the OTA update implementation of our SensGuitar. Why we can use OTA updates, you maybe ask. This is because we use Horizon, and if you take a deeper look or a short look at it, you see that this also comes from Toradex. And let's maybe take a real short look at what it does. Oh no, not the 1 hour presentation. So here.
When you need to update the system without an actual user doing the update in front of it, things start to behave quite interesting. You need to ensure that your system is still able to boot and function after the update, at least to the point of reverting the update if something went wrong. Otherwise, you may end up with what is called a brick device. It's called bricked because it's as useful as brick. And I'm not saying that bricks are not useful, but probably your device has been built for a different function and purpose. To avoid this issue, your update system must be atomic. This means that after you try to apply an update, the system will be fully up to date or in the previous state, not in a kind of dangerous in-between state. You should also be able to recover from a fail update or even to revert to the previous version if your latest update is not working as expected. This can be done by keeping two full images of your software. You update one, and if something goes wrong, you still have the other one. But this means having to use double the storage and having at most two versions of your system on the device. OS 3 work differently. It keeps a repository of all the files in all their different versions, and the actual file system is built with hard links to those files. This means that you may have more than just two versions on the device, and that usually does take much less space than the two full copies required by the previous system. OS 3 applies its changes at boot, and if something goes wrong and the system can't fully boot, it can revert back to the previous version after on the next reboot. With OS 3, you need to transfer only the file that you change between two versions, and this may help in saving bandwidth. Data can be transferred in background without affecting the current system operation. And this means that downtime during reboot can be minimized.
So I think this was interesting to see this and what it does. That's why we focus our containers to be compatible with Toradex. And this is why we have a starting module to use it directly from our embedded device and to start these remote updates directly from our SensGuitar. At the moment, this is work in progress, and it is not, OTR updates are not so easy as you can think of, and that's why we have not fully implemented this at the moment. The next are some more updates, features, DD. Yeah, the failure maps and the diagrams at the moment are also just working prototypes and does not work correctly. The strength map is like the diagrams show you how well you play. A major scale is our MIDI informations, and the feedback plane system is also a working prototype. The rest are completely prototypes, so I will skip the rest. Yes. So, as you can see, we have a lot of Docker working, or a lot of Docker prototypes and a lot of other Docker containers we use regularly. And you see that we have, for that reason, created a lot of Docker Compose files. A Docker Compose file is a way to start multiple Docker environments. As you can see here, we have a Western container for the graphical interface, and here are two applications. But if you like, you can also start with this with these Docker Compose files, even more complex systems. And for our private server at the moment, we will switch soon to a Docker Compose file, which then carry our whole internet presentation. I will stream maybe parts of this also here on Twitch, how to do this, but please keep in mind that I can stream everything therefore, because there are some passwords and so on that I could protect with something like Vault and so on, but this is not so easy and I have not done it before, so that's why I will check this first that everything worked. Yes. So today will be a little bit a shorter stream, because I would like to say thanks to all of you and to wish you a really nice day. And let's maybe stop with something we would also like to show you. And because I have a little bit more time, I will do this. As you can see, I've restarted the guitar. So the next part I would like to show you are some of our motherboard and what are some problems with this and what I would change the next time. But I have to prepare something for that. So please wait a second. And here we come. The first thing I would love to change is never ever do it again with Easy EDA. This was a major mistake for me. But as you can see, you can set up to 4 layer boards with Easy EDA, but I would never ever do it again. So let's in short say why. The first thing, everything like Untitled Chapter is do much better, is the 3D view. So if we open this motherboard in our 3D view. Also, I can show you a real one. Wait a second. In this program, none of the caps or the little resistors have a 3D model. I think so. I have tried to use the normal things, but nothing has a 3D model on it. The problem is that sometimes just in a 3D model you see that these caps were before a little bit too close, and with a 3D model you were able to see such things, and without the 3D model it was not possible. So maybe take a short look at our motherboard and what it does and what we will eventually change here. So please keep in mind that this will be changed from easy IDE to something better, to say to KiCad, which is also not the greatest. I have worked with KiCad a little while ago, but I'm not really familiar with it, and therefore I have worked a little bit, but really only a little bit with Altium, and the Altium Designer is it's extremely better. So here we have the worst one, and I will switch to a little bit better one. This is how I would call it. So as you see, we have here Eth Connection, and this Eth Connection have a little downfall because I have not read the datasheet correctly, and these are the pins for the lights you normally see in these kinds of ETH protocols. So they are not so important, but I have mismatched them and they should be connected to ground, and I've connected to 3.3 volts. So all my lights are never shown. This is a little bit bad. So you see here that we have our 1, 2, 3 LVDS connector, and if we take a short look at the schematic, you can see that we have laid them all out the same way. Also here is a mistake which I maybe would like to remove. If you take a real close look, you see that the good part is that the 12 volt wheel is on pin 39 and 40, but the 3.3 wheel is on 2 and 3 and not on 1 and 2. So this is not so great because you can easily shorten if you shorten the first or the fourth pin with the 2 or 3, you short the whole system, and that's why I would maybe change this also. The Apales connector has a lot of possible ways you can connect it, but as you see in our motherboard, we have done our very best to add as much as possible to it. So we have an SD connection on the bottom, you see here, a possibility for a SIM card header, which I'm honestly would remove because it was a little bit too much. But there was a strange idea in my mind, and I sometimes think it's better to try it and then to remove it later. So the other things you can see here are our USB FFC pin here and here. This FFC pin will never be used, if I'm honestly, because this FFC pin is just for the power and for the power connection, and the Apales will never ever do the USB power PD again. There was a plan to do this, but it's really hard, and so I've decided not to do this. If you ever design such a board, I give you one little advice. Every time you design such a little bit complicated board and you have the opportunity to add a little tactical switch for the reset, do it. In the long term, it will be great for you to have this. Because to have a physical button to reset the whole system is really a great thing. I would advise you to use this as much as possible in your designs. For our design, it was great. Also, we have a debug port, and this chip is a special chip for this debug port. And yes, all in all, I have to maybe find this connector in KiCad at our LVDS interface to KiCad. Find this UART chip in KiCad and add, last but not least, the SIM card and the ETH. So this is a little bit work, but not too much. As you know, we don't design the CPU or the real processing unit of it. Please keep in mind that this is a board in which you slot in an Apales. This is what you have seen like here. So let's select an Apales, let's select any dual and click start. Operation system. So this is an Apales, and you clip it in. And if you take a close look at our carrier board, you find the exact same counter header for the apparatus. It would also be able to solder it directly on, but then you can never remove it. And here's debug port also shown in the last part. So here's the debug port. So I have shown you a little bit Docker today. I've shown you a little bit our motherboard today. And I think that's it for today. Thanks everyone for watching. Have a nice day. And goodbye.